Hello class, I'm talking about measured numbers and sig figs in this video. Whenever we work in the lab, we are able to measure size, weight, and other information regarding the objects, like temperature. For measured numbers, we have two parts. One part we call it number, another part we call it unit. So measured numbers always have two parts, number and unit, like 73 degrees Fahrenheit, 2 centimeter, 55 grams. So they are some examples of measured numbers. In this slide, I'm going to show you one concept related to measured numbers. If I'm going to measure the size of this red or orange line that you see here, the size of this is larger than 2.7, and we have no idea about the exact measurement. We know that this is greater than 2.7. You may say 2.75, 2.76, 2.72. Because of uncertainty in this measurement, we may call the last digit of all measured numbers estimated digit. So if you are going to report your number 2.76, 6 is estimated digit. If you are going to report 2.75, 5 is estimated digit. So whenever we have any measurement, you are able to measure exactly by your tools. We call them certain digits, and always the last digit we have, we call it estimated digit. So for this example, you may say 2.71. 1 is your estimated digit. So that is why is difference between any person that measure the objects, we call it measured numbers. Estimated digit in the measured numbers. So 2 and 7 in these measured numbers, they are known or certain numbers, and 6 is estimated digit. Besides of this information, we need to know some other information regarding the measurement, and we call them significant figures. Significant figures play a key role in our class in chapter 2, and we apply significant rules for all chapters in our term. So it doesn't matter if we are in chapter 11, chapter 16. You need to know significant rules and apply this information to solve your problem. Regarding the significant rules, we should know two types of rules. First rule, as you see on the slide, all non-zero digits are always significant. If we have a measured numbers like this one, 65.2 grams, if we have non-zero digits, we call them significant. 1, 2, 3. This measured number has 3 significants. It doesn't matter our unit is grams, is centimeter, is seconds. Whenever we have any measurement, we may need to count significants. For this example, whenever you are asked how many significants are present in this number, you just need to count all non-zero digits. 1, 2, 3, 4, 5, 6. So you answer that 6 significants just reported in this number. Another rule that we may need to consider that when we have zeros, I may ask you to take a look at this slide first. It says when we count the zeros as significants with these conditions. Please pay attention to these two, and if you memorize this and the previous slide, you can easily answer all questions. If we have zeros placed between non-zero digits, we call them sandwich zeros. If they are placed in between of two non-zero digits, so like this example 29.05, we count this as significants. So this example we had 1, 2, 3, 4 significants. If we have like this example, these zeros are placed between non-zero digits, these zeros. So 1, 2, 3, 4, 5. They are placed between non-zero digits. So we have 5 significants. another possible sig-fix for zeros if they follow this rule. I may ask you to pay attention to this rule. Zeros placed at the end of a number with decimal place. At the end with decimal place. Two conditions. At the end with decimal. Look at this example. We have decimal and zeros are placed at the end. So we count them as sig-fix. So we may have 5 sig-fix. And for this example, we have zeros at the end. Also we have decimal. So we count them as sig-fix. So 1, 2, 3. So 3 sig-fix reported here. If you know only rule 1, you can easily answer all questions. But for our textbook, we need to know why we don't count these zeros as sig-fix. If they are placed at the beginning of a number, look, they are at the beginning of the number. We don't count them as sig-fix. At the beginning, we call them placeholder zeros. So here, for this example, we have 3 sig-fix. In this example, they are placed at the beginning. We call it 1 sig-fix. If we have zeros at the end without decimal, pay attention to this rule. If we have zeros at the end without decimal, so we don't count them as zeros. For this example, this 0 at the end, but there is no decimal, so we just have 3 sig-fix. Here, they are zeros at the end without decimal, so we have only 5 sig-fix. To remind you, if you remember only rule number 1, this slide, 0 between non-zero digits and 0 at the end with decimal, you can answer all questions. So let me give you some examples here. Question says, how many sig-fix reported in each example? For the first one, we have 0 at the beginning. We don't count this. 0 at the end with decimal. We count this. So it has 2 sig-fix, 3 and 0. For this one, we have 0 between non-zero digits. We count it as 0. And we have 0 at the end. So we definitely count this as sig-fix. 1, 2, 3, 4 sig-fix. Here we have 0 at the beginning. We don't count them as sig-fix. So we have only 1 sig-fix. And here for this example, like the previous example, we have zeros at the end with decimal. So we have 3 sig-fix. So 2 sig-fix, these 2, all digits sig-fix, here only 1, and here we have 3. I'm going to have a quick review regarding your math skills, rules of rounding numbers, like this one. If we have our digits 5 and greater than 5, we just need to round up. Look here, this example. It says round this number by 2 sig-fix, 1 and 2. I need to round this number. This digit is 4. We cannot round it up. We just need to drop it. So we should say 5.3. Another example here, 5.37. We are going to report our number by 2 sig-fix. 1, 2. We need to drop 7. 7 is greater than 5. So we need to round it up. So we may say 5.4. If our number is 5, like this example, we are going to report by 2 sig-fix. This digit is 5. So we round it up. We round it up. So we should say 5.4 as well. Please review the rounding rules and ask you this question. Report your numbers by 3 sig-fix. For the A, 3 sig-fix, 1, 2, 3. So I have to drop 7. I have to drop 5. So I have to drop these 2 digits. Always we look at the first digit. 1, 2, 3 sig-fix, we need to look at the 7. We need to round it up because we have 7. So we say 825, 825. For the second example, it says round the number to 3 sigfigs. 1, 2, 3. So we need to drop 4 and all digits after that. 4 is smaller than 5, so we just need to drop it. We call it round off. So 0.112 is the correct answer. One question that I am interested to share with you, it says report this number by 3 sigfigs. Here we have only 2 digits. So if we add 0 at the end, so 0 at the end with decimal, we count it as sigfigs. So we have 3 sigfigs right now. So 8.20, we have a number with 3 sigfigs. So I may ask you to take a look at your textbook and make sure you understand the meaning of sigfigs and rounding rules. Right now, I am going to talk about how to apply the sigfigs information and knowledge to calculate. Whenever you solve the problems, you need to calculate. So there are some rules that you need to consider for sigfigs. First one, whenever we are going to apply the sigfig rules, we need to classify our operators. If we have multiplication or division, if we have addition or subtraction, they are two different. First, let me talk about multiplication and division. If we have one of these two or both, the rule we apply is fewest significant figures should be applied for our final answer. What does that mean, fewest significant? Look at this calculation, 351.2 miles divided by 5.5 hours. We have division between these two numbers. If you divide this number by this number, your calculator gives you this number. Your calculator doesn't know anything regarding the sigfigs. So we need to apply sigfigs. How to apply? This number has 4 sigfigs. The number on the bottom has 2 sigfigs. Our answer needs to have fewest sigfigs. 4 and 2. Fewest sigfigs, it means we need to have 2 sigfigs here. So we need to round our number into 2 sigfigs. 63. So if we are going to round it, we need to drop 8 and round it up. So the correct answer for this one is 64. Is 64. So this is another reminding rule for the rounding. If your number is 5 and more, round up. Otherwise, we just need to drop it. So if we have this calculation in our class, you need to report your answer by 64. Any other numbers, any other answer is incorrect. Only 64 is the correct answer. Quick review. Rules of sigfigs when we have multiplication and division. If we have these two operators, fewest sigfigs or lowest number of sigfigs. Look at these numbers and calculation. 5.02 times 89.665 times 0.10. If you calculate by your calculator, you will find like this number. We are going to report our final answer by proper sigfigs. Multiplication. So we need to apply fewest or lowest sigfig number. Here we have 3 sigfigs. Here we have 1, 2, 3, 4, 5 sigfigs. And here we have 2 sigfigs. 3, 5, and 2 sigfigs. So we should report by 2 sigfigs. 4, 5. This digit is 0. We just drop it. So the correct answer is 45. Let me review another calculation here. Here we have division. Look at this example. 5.892 divided by 6.10. Division, fewest sigfigs. 4 sigfigs are here, 3 sigfigs are here. So we should report our final answer by 3 sigfigs. 1, 2, 3. I have to drop 9. 9 is greater than 5, so I have to round it up. 0.966. This is the only correct answer for this calculation. I may ask you to pause this video, take a look at your note, back here and answer the questions in this slide. In this slide, you are asked about report your answer by proper suffix. If you look at this example, this number times this number. Let me ask you one question. Do you need to use your calculator? You don't need to use, because you just need to remember number of suffix. Here we have 3 suffix, here we have 2 suffix. The answer with 2 suffix is the correct answer. The only answer is 2, it has 2 suffix, isn't this one? So 2 suffix times 3 suffix. If you use your calculator, that's fine, but you should report by 2 suffix. Division. So here we have 4 suffix, and here we have only 1 suffix. Because 0 at the beginning, we don't count them as suffix. 1 suffix and 4 suffix. So we need to have fewest suffix. 1. It has only this answer with 1 suffix. I ask you to use your calculator to check, see, are you able to get the correct answer or not. Here we have 3 suffix, here we have 2 suffix, 1, 2, 3 suffix, and 2 suffix. We should report our final answer by 2 suffix. So it might be the correct answer is 11 because it has 2 suffix and 0.041. This number has 2 suffix as well. So either 2 or 3 is the correct answer. But based on your calculation with your calculator, you should get the correct answer. The correct answer is 11. If you get another answer like this 0.041, please talk to me in our class. I'm going to show you how to use your calculator. In general rule, if you have numbers in the numerator of the fraction, if you have numbers on the bottom, just use the parentheses. If you use the parentheses for your calculation, you always get the correct answer. Another rule that we need to know for suffix when we have addition and subtraction. If we have addition and subtraction, the rule we apply for these two types of operators is totally different by suffix. Please pay attention. We are going to find fewest decimal places. Fewest decimal places. What does that mean, decimal places? Any digits after decimal points, we call it decimal places. Any digits after decimal point, we call them decimal places. In this example, we have the subtraction. This number minus this number. If we calculate by our calculator, we will find like that. But the rule says fewest decimal places. This number, first one, has 2 decimal places. This number has 1 decimal place. The fewest decimal places is 1. So we should report our final answer by 1 decimal place. 1 decimal place, it means 6.5. And we need to drop 1. If this digit is 5 or greater than 5, we need to round it up. So the correct answer is 6.5 because it has 1 decimal place. So to have a quick review regarding that, based on your textbook, we have the fewest decimal places for addition and subtraction. If we are going to add these 3 numbers, we will find by our calculator like this. It has 2 decimal places, 3 decimal places, 3 decimal places. So our answer should have 2 decimal places. So we should report by 9.20. I may ask you to work on this slide. Again, please pause, and after that, whenever we have calculator, we can get the correct answer. But again, like the previous examples, you don't need to use your calculator. You just need to take a look at the numbers. Here we have addition. You just need to remember that we have fewest suffix. Fewest decimal places, fewest decimal places. Addition and subtraction. Here we have 2 decimal places, 1 decimal places, and nothing. No decimal places. Wherever we have no decimal, 1 and 2, we should have a number with no decimal places. The only answer is this A. The correct answer is 2 157. For the second one, three decimal places and 1 decimal place. So we have subtraction, 3 and 1 decimal place. So we just need to pick 1 decimal place. Between these three, 1 decimal place is the correct answer. So 40.7 is the correct answer. I may ask you to work on the workshop that you have, and if you have any question, ask me. And the final thing, we need to know how to calculate when we have a combination of these four operators: addition, multiplication, subtraction, and division. I'm going to ask you a very simple form of rules you need to apply. First, follow order of operations. What does that mean? It means if we have any parentheses in our calculation, first we need to calculate the parentheses. So in this example, I'm going to calculate the parentheses first. So I'm going to write this number times this number, and if you calculate this by your calculator, you may find like this number. Here, I may ask you to pay attention. Never apply rounding rules in the middle of our calculation, only at the end. That is why we are going to keep all digits of our calculations. If you calculate that, you may find like this number. But if you remember, when we have subtraction, the subtraction rule was fewest decimal places. Here we have 1, 2, 3 decimal places, and here we have 2 decimal places. So we need to know we need to keep only 2 decimal places. 2 decimal places I underlined here. It means in these digits we need to consider only these 2 decimal places based on this calculation. Right now I have 3 numbers multiplied by each other. The rule for multiplication is fewest suffix. So here we just need to know how many suffixes reported in each number. 3 suffix, 4 suffix, 1, 2 suffix, because we underline only these 2. So we keep track of suffix here. So we have all digits, but we know that we need to consider only these 2 digits for our calculation. Rule here for multiplication is suffix. If we calculate like that, you will find like this: suffix, 3 suffix, 4 suffix, and 2 suffix. So we should report by 2 suffix. So our final answer is 19, because we need to keep only 2 suffix and we drop other digits. You have 2 examples on your textbooks. Please read them. If you have any question, ask me in our class when we are going to work on our workshop. Thank you guys, and take care.